I want to talk to you a little bit about standard unit vectors. So we've been thinking about vectors in terms of their components, but sometimes it makes sense to break down vectors into separate vectors for each component. That may seem overly complicated, but if you look at the standard coordinate system in 2 dimensions, wow, I have this already backwards. That is disappointing. So if we have a unit vector that's only in the x direction, so that is a vector that only has an x component, so 1 and then no y component, we're going to call that vector I. Now notice I put a hat on that in this particular case. Now I don't usually put hats on unit vectors, but I did talk about the fact that we might do that. But I am going to do that for these I, j's, and k's. And the reason to do that is just to differentiate from any other type. That this kind of lets you know we're dealing with the standard I, j, and k vectors. K vectors when we get to 3 dimensions. So we have an I vector for the x direction. We have a j vector for the y direction, so 0, 1. So notice that I and j have swapped zeros. And I have some vector v, which is equal to 3, 2. So the general case is that if I have some vector with components v1, v2, then v can be represented with those components as scalar multiples of the standard vectors. And you may ask yourself, why would we do this? What is the point? Well, there's a lot of powerful things that we can do as we learn more operations for vectors. And separating these things into their individual components allows us to analyze each dimension at once. It's really just another convenient way to represent the same type of quantity. Now, as if you deal with anything in physics and those, they love I, j, and k vectors. So it also serves to kind of prepare you for dealing with this in other disciplines. So to kind of look at this, and v in terms of I and j, well, if I said v equals 3i plus 2j. And you may say, well, how do I know that's equivalent? Well, if we use the scalar multiples here, that's 3 times 1, 0 plus 2 times 0, 1, which is 3, 0 plus 0, 2, which gives us 3, 2, which is our original definition of v. So this is just another convenient way to do that, and we're going to do an example to kind of put this all together.